Good morning, grade 11 senior high school students of Kawayan City National High School. For today's video lesson, let's talk about central limit theorem. To begin with, let us discuss what is a central limit theorem. If a random sample of size n is drawn from a population with a mean mu sub x bar and a variance of sigma squared sub x bar, and n is chosen large enough, then the sampling distribution of the sample mean x bar is approximately normal distributed, with meaning of summation of x bar is equal also to mu sub x bar, and that is equal also to mu sub x, and the variance of sigma squared sub x bar is also equal to sigma squared sub x bar all over n. This theorem says that regardless of the distribution of the population from which a sample is taken, we can choose a sufficient large n so that the resulting sampling distribution will approach a normal distribution. In general, n is greater than or equal to 30 is large enough for sampling distribution of the mean to be approximately normal. We will use the formula z is equal to x bar minus mu all over sigma all over square root of n, wherein your x bar is the sample mean, your mu is your population mean, your sigma is your population standard deviation, and your n is your sample size. Let's have an example. The average time it takes a group of senior high school students to finish a periodical examination is 45 minutes. The standard deviation is 6.5 minutes. Assume that the variable is normally distributed. The question is, what is the probability that if 50 randomly selected students will take the periodical test, the mean time will be more than 47.5 minutes? Let's have the first step, that is to identify the given information. We have our data, that is x, that is equal to 47.5, our mean or mu, that is 45, our sigma or the standard deviation, that is 6.5, and the number of samples, that is our n, that is equal to 50. Okay, now let's solve the problem using the formula to find the z-score, that is z is equal to x minus mu all over sigma divided by square root of n. Substituting the given in the formula, we will now have 47.5 minus 45 divided by 6.5 divided by the square root of 50, that will give us 2.72. That is now our z-score. Now for the third step, locate the z-score in the z-table for us to find the area of the z-score. We will now have the 2.7 and then the 0.02. And the area is 0.99674. Okay, let's solve it. That is 1 minus 000 minus 1.000 minus 0.99674, that is equal to 0.00326. Right, for the last step, state the answer. So, the probability that the 50 students will take the periodical test is more than 45.7 minutes is 0.326%. Another, using the same problem, the question is, what is the probability that if 50 randomly selected students will take the periodical test, the mean time will be between 43 minutes and 47.5 minutes? First step, again, identify the given information. That is your x, your data, that is 43 and 47.5. Your mean is still 45, your standard deviation is still 6.5, and your n, or the number of sample, that is still 50. Solve the problem using the z-score. Okay, first, we will consider our data 43. Okay, so we will substitute our given in our formula, that is 43 minus 45 divided by 6.5 divided by 50, that is equal to negative 2.18. Next, we will use now the second data, that is 47.5. We will substitute that in the formula. We will have 47.5 minus 45 divided by 6.5 divided by square root of 50, that is equal to 2.72. Now, let's locate the z-score in the z-table. Our z-scores are negative 2.18 and 2.72. Let's locate. There's the graph. We will locate first where is negative 2.1. Ayan. And then next is 0.08. Ayan. So, our data there, our area is 0.01643. Okay, for the second area, for the area of 2.72, let's locate where is 2.7, and then next is 0.02, and the area is 0.99674. Let's solve. Okay, that is 1.000 minus 0.01643 is equal to 0.98357. That is for the area of the first z-score. For the second z-score, that is 1.000 minus 0.99674, that is equal to 0.00326. Now we will subtract it. We will now have 0.98357 minus 0.00326, and that is equal to 0.98031. Now for the last step, state the answer. So the probability that the 50 students will take the periodical test in more than 45.7 minutes is 98.031%. Let's have another topic, that is solving problem involving sampling distribution of the sample mean. For the central limit theorem, take note that if n is greater than or equal to 30, the sampling distribution will appear to be normal. Thus, central limit theorem applies. Using the central limit theorem to convert sampling distribution to standard normal distribution, take note of this, mean of the sample is equal to the mean of the population. In symbol, we have mu sub x bar is equal to mu. The standard deviation of the sample is the same to the standard deviation of the population divided by the square root of the sample size. In symbol, we have sigma sub x bar is equal to sigma divided by the square root of n. So, the formula z is equal to x bar minus mu sub x bar divided by sigma sub x bar is also equal to x bar minus mu divided by square sigma divided by square root of n, where n is the sample size. Take note that must be n is greater than or equal to 30. Your mu is equal to, that is the mean of this x distribution, and sigma is the standard deviation of your x bar distribution. Let's have an example. Let x bar be the mean of the random sample in size 50, drawn from the population with the mean of 112 and a standard deviation of 50. First question, find the mean and standard deviation of your x bar. Second question, find the probability that x bar assumes a value between 110 and 114. And the third question, find the probability that x assumes a greater value than 113. For the first question, we know that our population mean is also equal to our mean. So, our mu sub x bar is equal to mu that is equal also to 112. Okay, so and then our sigma sub x bar is also equal to sigma divided by the square root of n. We have the value of sigma that is 40 and n that is 50. So 40 divided by the square root of 50, that is equal to 5.66. Number 2 question. Okay, So find the probability that x assumes a value between 110 and 114. So we have a data there that is 110 and 114. So we have the probability of 110 is less than the x bar, and that is also less than 114 is equal to probability of the 110 minus mu sub x bar divided by sigma sub x bar that is greater than z, that is less than z and less than at 114 minus mu sub x bar divided by sigma sub x bar, that is equal to probability of 110 minus your mu, that is 112, divided by your sigma, that is 5.6568542494923 is less than z, is less than 114 minus 112, that is your second data, divided by 5.6568542494923. Sir, saan po nakuha yung 5.6568424949238? That is 40 divided by square root of 50. Okay? Nag-round up lang ako dun sa ating 5.66. Okay? So next step is to simplify that. We will now have P of negative 0.3533533959 is less than z is less than 0.3533533959. Okay, so since those z scores are very large, we will simplify that. Okay, so i-round up natin. That is equal to probability of negative 0.35 is less than z and less than 0.35. So hanapin natin sa z-score yung area, sa z-table yung area ng negative 0.35, and that is 0.36317, and yung area ng 0.35 sa z-table natin, that is 0.63683. So subtract natin sila, we will have a value of 0.27366. So the probability of 110 is less than x bar is less than 114 is 0.27366 or 27.366%. Okay? For the third question, the probability of x bar is greater than 113, that is equal to probability of z is greater than 113 minus mu sub x bar divided by sigma sub x bar. We just substitute the given in the formula. We will now have probability of z that is greater than 113 minus 112 divided by 5.6568542494923, and that is probability of z is greater than 0.17677669529. Simplifying it, round up, we will now have probability of z is greater than 0.18, that is equal to 1 minus the probability of z is greater than 0.18. So we will locate 0.18 in our z table. We will now have 1 minus 0.57142. Subtracting it, we will now have the value of 0.42858. Therefore, the probability of having a greater value than 113 is equal to 0.42858 or 42.858%. Another example, the numerical population of grade point average at college has a mean of 2.61 and the standard deviation of 0.5. If a random sample size of 100 is taken from the population, what is the probability that the sample mean will be between 2.51 and 2.71? Okay, so first, let's have our mean and the standard deviation. We know that the population mean is also equal to the mean. That is equal to 2.61. And the standard deviation, the population standard deviation is also equal to sigma divided by square root of n, wherein your sigma is 0.5 and your n is 10. So we have now 0.5 divided by square root of 10. That is equal to 0.05. Okay, so let's now solve what is the probability of having 2.57 is less than your x bar is less than 2.71. That is equal to the probability of 2.51 minus mean sub x bar divided by sigma sub x bar, that is less than z, that is less than also to 2.71 minus mean sub x bar divided by sigma sub x bar. That is equal to, substitute the given, probability of 2.51 minus 2.61 divided by 0.05 is less than z is less than 2.71 minus 2.61 divided by 0.05. Simplifying those two, we will now have probability of negative 2 is less than z is less than positive 2. Okay, so let's simplify it. We will now have probability of z is less than 2 minus probability of z is less than negative 2. We will locate positive 2 in our z table. We will now have an area of 0.97725. We will locate the area of negative 2 in our z table. We will now have value of or area of 0.02275. We will subtract that. We will now have a difference of 0.9545. Therefore, the probability of 2.57 is less than x bar is less than 2.71 is equal to 0.9545 or 95.45%. Next topic is all about estimation. Let's define what is estimation. It is a process of making inferences about the population based on information obtained, take note, from a sample. There are two types of estimation. First one is the point estimate. It is the sample mean x bar of the population or the mean mu. It is the take note. It is the numerical value which gives an estimate of the parameter. Second type of estimation is the interval estimate. It is a range of values used to estimate the parameters. It can be calculated using two numbers or values which may or may not contain the value of the parameter being estimated. Let's have an example of point estimate. The problem is estimate the mean consumption of 6 families in 1 month if their expenses are 14,200 pesos, 15,500 pesos, 16,800 pesos, 17,500 pesos, 20,000 pesos, and 27,000 pesos. We will use the formula of the mean, that is equal to mu is equal to summation of your x, your data, divided by your n, the number of your data, and that is equal to 14,200 plus 15,500 plus 16,800 plus 17,500 plus 20,000 pesos plus 27,000. Simply divided by 6. Simplifying it, we will now have our mean or mu that is equal to 18,500 pesos. And that is our point estimator. Let's have an example of interval estimate. First one is the average family income in the province A is 300 pesos to 450 pesos a day. Second, the average lifespan of indoor pets is 6.5 to greater than 0.8 or less than 0.8 years. Number 3, the average scores of students in Math 1 exam is 70. Is less than, mean is less than 85. Thank you for watching and listening. I hope that you learned something today. If you have a question and clarification, don't hesitate to message me in my messenger account, that is Kim Francis Season Along. Till next video lesson, bye!